Initially suggested by the Chief Engineer of the Light Aircraft Association, our project aims to modify the university's Sherwood Scout aircraft into a variable stability demonstrator. The system is designed to change the pitch characteristics of the Scout to mimic other aircraft or different centres of gravity locations within the same aircraft. One of the many applications of this project is the LAA annual test pilot event, where our system can be used to reduce the number of flights as stability characteristics of multiple aircraft can be demonstrated in one single continuous flight. The final design output consists of 6 sub-assemblies, which work together cohesively to achieve our aim. 5 are mounted internally. These are the control panel, deadman switches, front stick mechanism, servo rack, rear actuation system and pitot-static tube, which is mounted on a jury strut outside the influence of the propeller wash and wing downwash. The system is operated by selecting a preloaded flight characteristic model using the rotary switch mounted atop the dashboard on the control panel assembly. The pilot then uses the P2 control stick to control the aircraft. The pitch axis has a resistance applied by a footwell mounted actuator which accurately reflects the control feel of an aircraft which the system is simulating. The roll axis is unaffected by the modification, which is achieved through a scissor mechanism mounted at the base of the control stick. The servo at the front of the aircraft senses the movement of the stick and supplies position data to the computer control system. The stick position input from the pilot is fed as an elevator deflection into the flight dynamics model of the target aircraft. The target aircraft pitch rate from this model is fed into a signal tracking model which calculates the modified elevator input. The target aircraft flight speed, stick position, load factor and vertical velocity from the real aircraft is fed into the force feedback modelling. This calculates the stick force the front servo must provide through the P2 stick assembly. The pilot also experiences the target aircraft response through the Scout's response being modified. The modified elevator input command from the system is passed to the rear actuation system, which moves the idler at the rear of the aircraft. This is mechanically linked to the elevator control surface, and it induces a pitch response from the aircraft which portrays the aircraft being mimicked. The result of which can be seen in X-Plane 11. In real time, the system determines the modified elevator deflection necessary to augment the Scout's pitch rate response to that of the target aircraft. An appropriate stick force is also generated. The system demonstrates the correct response when matching a target aircraft with the same centre of gravity configuration, a Boeing 747, and an F4 Phantom. Note that at all times, the Scout is stable, and we're only modifying the extent of the elevator deflection, so therefore the system is safe to use. Due to COVID restrictions this year, the project was limited to the design and certification phases. However, detailed instructions, technical drawings, and a bill of materials have all been provided to ease the transition to the new team who will carry out the future work.